Right. So, here, Sukma. So today we are going to discuss about the roofing. Roofing itself contains two parts, which is the structure and also the covering itself. So this is the top. This is the out the toppest part. The most. The location is in the highest place of your building. So I hope that and usually students try to avoid complicated roof or maybe they tend to avoid using pitch roof because it's more complicated than a flat roof, because flat roof is easy. You can use a flat slab like what you have used as a floor. But for the roofing, it's more difficult or more complicated if you want to use the pitch roof. But considering the practice, I think all over the world, the pitch roof is better than the flat roof, because, for example, in our country where the rain is very hard and the intensity is quite high, you want to throw away or avoid the accumulation of the rainwater on your roof. So that's why the pitch roof is better than any other type of roof. And then, meanwhile, in temperate climate, for example, or cold climate, it's better to have a pitch roof, because when the snow come, then it will be a lot easier to slide it down rather than having a flat roof, because when you have snow, the additional weight of the roof is increased. Snow is a lot heavier than we think. It's like an ice, and if it is accumulated a lot, then it will definitely add more weight into the roof, and it can create collapse in the building. That's why pitch roof is actually more versatile for people for buildings, but because it's electricity and also sometimes people don't like the shape, they tend to use another type of roof. But for this course particularly, we are going to talk about the pitch roof. Um, So today's content revolves around several parts. First is about the general description or general explanation about pitch roof, and then it will be followed by the anatomy as usual. And then the next one is about the load distribution and the materials that is related to the assignment that you have shown, that you have been explained before. And then next we will be discussing about the construction process, and of course, it's related to the construction drawing. So let's begin with the first thing about pitch roof. In this course specifically, we are going to talk about the pitch roof, because if you are talking about flat roof, it's a lot easier to maintain or to understand, because it's definitely having the same anatomy like the floor slab, so that we don't have to explain more. But the pitch roof has different type of anatomy and different type of expression, so that you have to understand the pitch roof itself. Wait a minute, I need to change it to arrow. And then if we are talking about the pitch roof or roof in general, is having several functions. The first function is, of course, the climate barrier, because at the roof is considered something that is the outer part of your building. And as I mentioned before, roof is becoming the highest part of the building construction. And of course, it becomes the climate barrier. It's not only for the sun, but also from the wind, as well as rain, and of course from snow. So that's why roof is really important. And then we are talking about the strength and stability. For the system itself, when we have a structural system, we have to consider what roof we are using, because it will affect directly to the whole system, because even though it's in the top, it's on the top of the your whole system, like the superstructure. um, but again, if we are talking about the roof is not habitable, it must be very lightweight because this is in the top, and if it's not used, then the efficient one will be the lightweight one. So instead of adding more weight to the whole system, we have to think about how to reduce the weight or using as efficient as possible for our roofing. Next is about the fire protection. It's a must actually for all part of the building should be fire protected. But again, if we are talking about fire protection, roof is usually created from several materials that is really easy to get burned. So that we have to consider about the protection. And the last one is related to our design manifestation, which is aesthetics. A lot of the time, we are seeing the expression of flat roof more and more in the practice nowadays. And maybe you also considered that flat roof is becoming more popular. But again, if we are considering the climate and how we live in not only in tropical country but all over the world, the pitch roof is more beneficial. So if we are talking about the aesthetics, we actually have the responsibility to create the aesthetic from the pitch roof itself. So the pitch roof is not boring. We have to create something that is dynamic enough. So it's not something that like, okay, the shape is just like that and I'm okay with it. So it's not like that. So don't think that pitch roof is only like the governmental building that is really boring, but this is your responsibility to create something that aesthetics from pitch roof. And that's why the function, one of the important function of roof is the aesthetic itself, because it is the highest part of your building and it's absolutely visible from the people outside to see it, or maybe in the design process as well. You can see it from the top as you create a site plan, so that it relates to aesthetics as well. Now, after we talking about the function, I think the function is really easy to understand because roof is really visible for you in your daily life. Now we move on to the types of pitch roofs. There are three actually, but the combination is a lot more than, and you can find it online. So basically there are three. First is mono pitch roof, and then the second is gable roof, and then the third one is hip roof. This all is related to the roof that is pitch or having a different angle between the horizontal and the roof itself. So this three is the basic one, and then I will show you several modification or development of based from these three fundamental roof. So first we are talking about mono pitch roof. So we can call it lean-to as well because it's only one. It's really easy. You can find it everywhere for the minimalistic building that for building that is labeled minimalistic, usually use this. And more and more people are encouraged to use this nowadays. It's a lot easier than the like a couple pitch roof. I will show you in the next slide. And this is the simplest one if we are talking about the pitch roof. Again, if you are talking mono pitch roof, it's usually applied for a narrow building. It's not that it doesn't have like a very long or very big. The width is very big. It's not like that because imagine if you have like a very long building and then you create only one pitch roof, then you the area here, for example, if you take a look at an imaginary line here, it will increase and become bigger. Unless you try to create another space that is inhabitable in those areas, then it's fine. But if you are just trying to deliver a roof and it's only mono pitch roof for a very wide buildings, then it wouldn't be efficient enough. Next is the gable roof. It's also very easy to find, and many design has already incorporated this type of roof. I noticed that recently there are many design that is showing this expression of roof. So many modern nowadays, what the market called modern style, using this type of gable roof. Even though they didn't show that, for example, in this image, the roof is protruding from the gable. The gable is here, located in here. But nowadays, we are trying to create those image of gable roof, and then use another roof inside it. So there are so many expression on this gable roof nowadays. It becomes more popular, and it gains, I think, popularity between amongst young people who wants to build their new home. So next is about the hip roof. This is your assignment. So hip roof is basically already used in like a traditional or vernacular architecture, usually in Javanese architecture, but also it is the common one that is used for any buildings that is located in not only in tropical country, but also in temperate climate countries. So this is very common roof that you can see. So the difference between this pitch roof, the gable roof, and the hip roof is actually here, this side. So we called it the gable roof because it has a gable here on top, while this one, you don't have gable. It's fully protected by the roof itself. So those are the difference. I hope that you don't confuse between those. And in Indonesia, we call it gable roof pelana, atap pelana, while for this hip roof is called limas. So those are the terminology for this roof. So those are the three basics fundamental shape of pitch roof. But in the practice, you can have many type of configuration starting from those three basic things. For example, you can have a skillion and lean-to. So you have basically two type of roof. It's like two mono pitch roof, and you attach it together. And it usually have different height. So even though you don't have to mention the terminology, but you know that it's actually mono pitch roof, two mono pitch roof. And then this is open gable. So, well, we call it gable as well. And then there is box gable, means that the gable area is protruding. And then there is Dutch gable, which is actually very familiar, commonly found in Dutch, but we can also find it in Indonesia for colonial buildings mostly, because it tries to incorporate the Dutch design in the past during the colonialization. And then also we can have hexagonal gazebo. So this one is basically trying to explore the basic shape of pitch roof, but having one point on top. And then you have another gherkin head. So gherkin head, this one, it's just cut it in the sorry, in the edge like this. And then you have Dopmer. So Dopmer is like this. I think you can see it in the US or European country housing, that like this. And then you have hip, that becomes now that now is becoming your assignment. And then you have hip and valley. So hip and valley is actually the combination of several hips, and then you try to maintain between those two so that the rainwater is not collected into one side. And then another thing that is almost like the hip and valley is intersecting or overlaid hip like this. So it can be mixed between the gable and also the hip roof. So there is no restriction on using roof, specifically pitch roof or any other roof. So it's your decision whether this one conveys your design intention or not. Or maybe you can use cross hip. Or even there is another example like Cambril, and then Mansard, butterfly. So butterfly, it's like the monopitch roof is attached together, but on the other side, and it creates something valley in the middle like this. And then you have M shape, literally like M shape, and then you have side trucks, and then you have shed. So shed is actually mono pitch roof, but some people call it shed as well because the configuration is almost the same. So this is why I tell you that actually pitch roof have a lot of potential. So we don't have to stick onto like only open gable or maybe only hip type. We can create so many configuration, even something that maybe in the future you can create but not listed here. So it's really up to you to create a roof. But again, the benefit of using pitch roof is it helps rain or snow to get away from those area as soon as possible compared to flat roof. Now, the most important thing about roof if in Indonesia is rain. So rain is becoming the most important part because the rain is really hard and the intensity is quite high compared to maybe temporal climate. That's why we are using pitch roof. As you can see here, this is what it looks like in our country, even though it's not in our country because it has like a chimney. But this is like bucket rain. So they mentioned that in Indonesia, it's like a bucket rain. It means that the water is really hard and the intensity is really high. And then so that we are going to think about how it will deliver the rainwater itself. So whether we throw it away directly like this, like what usually applies to a freestanding building where you don't have attached area with the neighborhood or you don't have any limitation. So you can throw it away directly like this. But also you can create something like gutter like this so that you can manage the rainwater from the roof so that it can be collected into the pond or any other storage that collects the rainwater. So this is why we think about gutter as well during creating or designing roof. But in your assignment, you haven't find any gutter yet. It's a freestanding one. So this is how it looks like when it's raining, even though you didn't realize it, but you can observe your home. I don't think this month is a rainy season, so but I have heard in Jakarta there are some rainy days nowadays, so you can check if during the rain how it looks like in your room, the rainwater runoff, how it looks like. Is it like this or it is protected like this? So you didn't find anything like this, then you can understand that, oh, if it is free fall like this, then you don't have gutter on in the edge of this part. But if you have gutter, then it will be like there is like a clear border in this part. So again, roof usually have extension like what we give you in the assignment. So the extension itself is not only for sun protection, but also for rain protection. Because in Indonesia, again, the intensity of the rain is high, so that we have to protect the wall or the body of our buildings. Because if it is get too wet, then it becomes prone to dam, and then you can create something that is not really desired by the inhabitant or by the people inside. So you want to avoid that. That's why usually if you can see people during the rainy days, usually people try to protect themselves in the area like this. So it is the outer part of your building. So that's why you have extension on your roof, compared to if you try to compare with any other design that doesn't have extension, then they will directly expose to the rain water, even though they try to add, for example, water resistant material and stuff, but still it is quite unbeneficial for the inhabitant. So we are talking about rainwater runoff. So again, if we are talking about the pitch roof, we are talking about how to eliminate the water or maybe snow from the top of our building, because this is the protection, the first protection from anything outside, like literally anything on top of us, not only sun but also water. That's why the height of the pitch determine how it will deliver the rainwater runoff. So the lower a pitch, the lower rain runoff. Again, if you imagine like you have a surface and then you try to make a slope on it, and then you can check the speed between how it travels from the top to down, then you can understand that the lower a pitch, that it means definitely the lower rain runoff. So you have to think about how to mitigate the accumulation so that you don't have a very heavyweight roof during the rainy season. And then, of course, it will relate to the appropriate gutter size. If you are talking about a very low pitch one, like almost flat, then you have to think about the gutters, because it will accumulate a lot of water because it's not directly go down. And so you have to think about the gutter size. And then you also have to think about the gauge and lap problems. We are using materials. In the next slide, I will show you several methods on attaching the covering for our roof. So the gauge and lap problems is something like, I don't know whether you experience it or not in your daily life. So usually when the rainy days is accompanied with a strong wind, if you have traditional house, for example, and you are using terracotta tile, usually there are some part that is misplaced because of the wind, and then it becomes problem because actually they are not attached from anything, and then it misplaced and it creates opening, and then the water come into your building, and usually it will give a sign from your ceiling, and then you can check, oh, there is something like a wet mark on your ceiling, means that there is something wrong with your roof. So those are like a very common problem that you can find from pitch roof. So even also the flat roof has the same problem as well, because roof is the first protection from rain and also snow. Next, we are talking about the anatomy of the roof. If we are talking about the anatomy of the roof, we are talking about first the structure, because if we are talking about the covering, it's only about the covering. So the covering is only on top of the structure itself. So this is, I have explained it in the previous one, but I will explain it more again. So you have this one supporting wall. In European country, they call it supporting wall, but we have ring bulk here usually, but and then we have the rafter or trusses if you are using steel. And then you have here, you try to build, you start to build the structure to attach or to hold on the covering. So again, roof, unlike any other elements of structure, it only have the job of this part, or the job of roof is trying to protect you. And the load is only because of their own weight. So it doesn't have to distribute any load from any other part of structure. So it just have to hold on to the covering on top, and then other than that, doesn't have any function as distributing any other load from the top. So those are what roof is. That's why it's usually using a very lightweight material such as wood or steel, so that it doesn't add more weight for the elements underneath it. This is what it looks like. Again, this is gable. There are a lot of elements here. You have to understand what is it actually like, or maybe what is it, what the function is. I will explain it in the next slide related to the section, because in section you have to understand that um, each part has their own contribution toward how the building stands. So this is the gable if you are using gable roof. And then you have rafter, this is rafter, and then you have purlin, you have joist, and this is the ceiling. The ceiling here is attached directly to the joist, but you can do another stuff, which is hang underneath it, so it doesn't have to attach to the joist. And then again, there are many other parts that you have to understand, like valley, like this. Valley is literally like what you will translate valley. Valley is valley, so that's the area of the down part. So when you have rainwater, it doesn't stuck here, so it will run off like this. And then you have chimney flushing. So actually I will talk about the flushing. We don't use chimney here, but the flushing is used still. And then roof fan, some of the configuration of roof using roof fan to reduce or to mitigate the possibility of overheating during the summer. And then you have hip. Hip is the definition of your roof. And then you have ridge. Ridge is the top part of the roof, like this. Here is the gable, and you have soffit. Soffit is underneath, and you have fascia is the area here. I will explain it in the next slide. Now we are talking about the first anatomy, that is called eaves. So eaves is actually the area here. Eaves is the lower portion of the inclined roof, which is projecting beyond the outer face of the wall. This is what you have to design. This is what you have to draw when you have the assignment. I believe that there are some maybe 1.2 meters outside the wall. So that's the area called eaves. So the eaves main function is to prevent rainwater to pour from the roof directly on the exterior wall, as well as protection from sunlight, because it's protruding and it gives you more coverage so that it avoid the rainwater as well as sunlight. That's why it's an important part so that you can put it on your roof. And then sometimes eaves are highly decorated to increase architectural beauty. Again, in the classical architecture or vernacular architecture, you can find that the eaves is really full of decoration, because this area is actually not like something that is very structural, but it's really important so that you can put decoration on that. So this is the first thing that you have to do about, you have to understand about eaves. And then you have gable. Gable is very simple, the triangular upper part of the wall at the end of a ridge roof, like this. Usually it has the same materials with the down part, which is like wall, but in, I believe in, maybe you have, if you visit Central Java, at least Madiun and so on, which is actually near the Central Java, you can find that the top of it is using wood, which is the same material as the roof itself. So it can be anything, but the area here, when you have something like this and it's not pitch or it's not roof, then it's called gable. Next is about flushing. So flushing is really important, because not flashing. So this is the elements that is important as well when you are having not freestanding building. Because our area nowadays is very limited, so always we have attached roof to another wall or any other part. So this flashing is used for protection that. So a strip of impervious material, usually metal, used to exclude water from the junction between a roof covering and another part of the structure. Because when you have two surfaces together like this, and it's not like one surface that you bend, of course there is a leak on that, definitely. And we have to and make sure that our building or our roof is free from that, because it will become a problem for us. It also prevent moisture from entering the wall and roof through joints in copings, parapet wall, and other penetrations through the roof plane. So again, this thing you can find it in the valley as well, not only in the junction between roof and other part of structure, but you can also find it in the valley. So the flashing is something that it protected, like that protects the leak or the gap, even it's very small. So it protects the gap so that the water doesn't come inside the building. Next is about the ridge. So ridge is something that is on top of it. So in Bahasa, you can call it gording. So this is the ridge, and usually a ridge is having a ridge cap. So you have a cap on top of it. It can be from the same material like your covering, or it can be tiles or any other materials. But sometimes also for example, in Chinese architecture, you will have decoration on top of it. So those are the ridge. So the main part at the top is called ridge. And then we have fascia. So this is wooden board fixed. Well, it doesn't have to be wooden. It can be anything, but the surface that is located in the feet of the common rafter at eaves. So the location is in eaves. Here, this is the fascia cover. It's actually the ends of the lowermost roof covering material rest upon it, so that it protects your whole structure, your roof structure from dirt and also from water. So this is something called fascia cover like this. So it's I don't know whether you can see it or not from your house. So maybe if you take a look from outside and then you take a look on your roof, you can see the fascia part of your roof. So this is what it looks like, and this is how it located. Next, we are talking about the load distribution. The load distribution, I think I will repeat this image again, because as you can see, if we are talking about load distribution, it doesn't distribute any loads from above elements, because this is the highest part of your building system or structural system. But it has a main function to distribute the load from wind, from rain, as well as snow. That's why if we design roof, we have to think about how lightweight is it, because the more lightweight your roof, the more efficient then your structure will be. Because if the roof is heavy, then you add more loads into your buildings like this. That's why we have to think about very lightweight material as our roof. This is what it looks like. Even though we don't have any elements on top of it, we still have natural load such as wind, snow, and also rain. If you are thinking about rain or maybe snow is not that heavy, well, when it comes to accumulation, it becomes really heavy. Imagine that you have a bucket of water and try to put it on top of your try to lift it with your hand. It will be heavier than if you try to grab water with your hand. That's why accumulation is not something that must be avoided in roof. So because the accumulation can damage the roof itself and can make the building collapse. For example, I think I have given you the example when the Merapi eruption during, I believe it's 2014. So many houses in the area of Magelang, or in the area of Central Java that is located near the Merapi, the house is very fragile, so that when the Merapi erupted, the ash is accumulated on the roof. Because unlike snow or water, ash doesn't have like liquid material in it. So it will be collected or will be attached to the material itself. It's like a very small dust, but it's accumulated a lot of it. So that when it is accumulated on top of the roof, it becomes small. The weight is add up, so that it becomes heavier. And the heavier your roof, uh, again, it will affect the column ability, as well as the wall underneath it. It will be affected by it. So that's if you try to take a look several news on during those days, that you can find several buildings that is very old or fragile has collapsed, not because of the earthquake, but because of the ashes. It also applied to my house. So my house is not using like there are part of additional part of my house that is not using a column and beams. They just use um, directly use a brick, so that there is no structure on it. And then when it happens, it almost collapsed. But thankfully, the after the eruption, several hours from that, there is rain comes, so that it wipes off the ashes, and there is no problem with that. That's why you have to think about the structure, not only because of the lateral and then also the weight itself, but possible weight like snow, as well as snow can slide off, but ash is not. So some of my neighbor in Magelang, they try to wash it off with water. So you bring your bucket and then try to throw it on, try to throw water on top of this roof to avoid the breakdown, the additional ashes that will make the roof become heavier. So that's why you have to think about that as well. And if you take a look on the truss, there are two type of response in this part. So there are compression and also tension. If we try to take a look at this particular shape, if we try to push it here, this is the load from above. And then when you try to push it, of course, there will be deflection like this. That's why you have this one, so that it doesn't deflect. And you have deflection in here as well. So you need to pull it so that it doesn't goes down as well. So this actually, this part helping to maintain the shape like this, so that it doesn't break down or having deflection. So this is the main thing about the trusses or maybe rafter. So any other thing is not like distribute. It doesn't actually distribute the load, but it's trying to manage its own shape at the first thing first. And then we are talking about materials now. So the materials, if we are talking about materials on roof, there are two materials that must be considered. First, the material of the structure, and the second is the material of the envelope or the cover. So for the material of the structure itself, I have shown you in the previous lecture, and also your assignment. There is called wood rafter. This is the first material that is available in Indonesia, and also commonly found in all over the world, which is wood rafter. And then next, the more lightweight one is the steel trusses. So it's becoming more popular because it is easily attached, and it doesn't have more more weight compared to the wood one, and the durability of metal becomes one point like benefiting that preferred by designer as well as clients, so that they don't have to take care of their rafter, the wood rafter. Next is about the covering. So the covering, I will talk about two materials that is becoming your assignment, but in real life there are more and more materials that is applicable for roofing. So you can find it by yourself, and it throughout your studio you will face them, you will cope with them, you will eventually learn about them. So the basic thing you have to understand is the first is the terracotta tiles. As you can see here, it has two typical shapes, even though when you are trying to go to market, there each region, or for example Central Java, East Java, even each kabupaten, they have their own shape of tiles, terracotta tiles, and it becomes something that is really can be distinguished easily because of maybe the circular part, or the weight, or the big the sizing. So, or maybe the decoration, because there are some decoration as well in terracotta tiles. So basically there are two type of terracotta tiles. First is the rounded pan shape tiles or flat tiles. So this one is the flat tiles. This is the rounded pan one. If you try to use, what is that? Oh yeah, SketchUp, I believe that you find this texture as well, the rounded pan shape tiles. Those are the tiles that are using for particular surface in SketchUp, but you can actually in real life in Indonesia, we are using mostly or majorly building use these flat tiles. And then it is traditionally made from locally sourced clay, molded into a tile shape and fired in oven or kiln. So I don't know whether you have experienced it or not, or have ever visited a place that give production of clay tile or terracotta tiles, or maybe brick. So basically you have a clay and then you put some water on it, like making dough for your bread. It's almost the same, but the color dough is white, but clay is a little bit like gray or brown, something like that. So it's a darker color. So you mix it with water and then you put it on moldings. Moldings is cetakan, something that shaped the roof or the tiles. That's why each area, for example, in Indonesia, each kabupaten have different moldings, and it becomes the expression of their culture. So if, for example, you buy something in West Java, the shape is not totally the same with the East Java. So everything is having their own additional design for the terracotta tiles. But this one is made from the traditionally or locally sourced clay. And then after you put it on the moldings, usually you wait for maybe 1 or 2 days, and then you take it off first and then put it on an open area, usually to make it dry first from the water that is added during the mixture. So, and then after it dries, you put it on an oven, like a very big oven. I remember that maybe 10 years ago, because nowadays the area around me develops fastly. 10 years ago, my neighbor still produced brick and also terracotta tiles. Usually the production is located in an open field where and used the waste from the field itself. So it will be burned there. So in a long time and a very high temperature. And then you can see that the smoke is dark and goes up. and that's the production time. And then because of this process, so you have slightly porous, so that it's actually not literally water resistant, but it's waterproof. So it's like if you have a kanken bag, it's not actually water it's not water resistant, it's actually waterproof. So the if you just try to splash water, it will run off. But if you got caught in the middle of a heavy rain, then of course everything inside your bag will be wet. So it's almost the same. So it's actually make those water slide down. But if you put it on a long time, then the water comes inside. So that some practice used waterproofing materials. So they use more additional covering like coating, so that it can protect you from the rain specifically. And also it can protect, it gives you protection from wind and any other elements such as dust and stuff. For the terracotta tiles, the placement itself is an overlapping. So it must be like overlap like this. This arrangement is assigned like that because it has to stop the rainwater from leaking through the roof. So there is no bolting or nailing in terracotta tiles. Everything is actually only put like this. So it's overlapped. Next, the benefits and the drawbacks of terracotta tiles. First is about the local availability. Of course, it becomes it's easier to find terracotta tiles, but nowadays it becomes something exotic, which means that it becomes rare compared to the previous days of building development. So, but still, it is a locally available. And because the materials is actually coming from like a very easy find material such as clay, that's why the local availability becomes one thing for sure. And then also it's related to the craftsmen more. Back in if you are going to all over Indonesia area, not only in the city, try to visit a suburban area, then in those part of area, they must be familiar with terracotta tiles rather than any other materials for roof cover. So this one becomes, that's why the local availability here is a plus, because compared to metal roofing, it is widely spread. The knowledge is widely known for all people. But if we compare in the city nowadays, people in the city try to leave these terracotta tiles using metal roofing because it's quite quick, and it doesn't need a lot of time or a lot of labor to put or arrange the tiles itself. Next, we're talking about the energy efficiency. It's a plus because the material itself, the clay itself, has what we call in physics called like thermal ability. So, well, actually, because it's clay, it's thick, and it has something that can absorb the heat. So it makes the area underneath it more slightly cooler or having lower temperature if you compare with the metal roof. If we are using an apple to apple comparison, means that you don't put any other layer underneath it, because from the nature of the building, the material itself, first it has a thickness, like the thickness is quite big, and then so that it helps the help to mitigate the heat transfer from the outside to inside. That's why when we are talking about the building performance, it will increase the energy efficiency. But if we are talking about the production, nowadays we consider that this one is becoming the pollution of our world, because the burning the burning process. But nowadays we try to in developed country they try to produce terracotta tiles without burning process, so that they don't create like heat and also create pollution to the air. And then we are talking about the durability and resilience. So this is a plus and minus. It can be benefits and drawbacks. For the durability and resilience, because it's natural made or clay, the material itself a clay, you can see that the material itself can stand for a long time. It is stiff enough compared to metal that is really thin, but it can hold its shapes, so that we can call it durable and resilient. But if we are talking about it, the strength or the rigidity of itself, when you drop it, it will break down. So that's why I mentioned that it is a plus and minus. It can be very beneficial using terracotta tiles because it can be very stiff because it is solid materials, but because of the softness of the bond from the particles, when you drop it, then it will break down. Or maybe the case is not dropping it out, but if you try to repair your building, sometimes the people on top of it just accidentally step on, for example, fragile structure, so it will break down as well. So it's a lot easier to be like that. And then the last one about the benefits and the drawbacks is about the weight. It becomes the minus and also plus. The minus is, of course, it is heavy compared to metal roofing. And this one become minus because if it is heavy, then it will add more load or gravity load for the structural element underneath it. But there is a plus point from this heavy material, this heavy nature. As I mentioned before, that actually the force or the load that has to be resisted by roof is not only rain and snow, but also wind. So imagine that it's a lightweight one, then it will be blown off easily with the wind. That's why it becomes a plus point from a wind view, that it is having its own weight so that it doesn't blow away easily. But I guess when you have like a tornado or very heavy wind, then it can shift, the arrangement on the roof can be shift as well. So we can see that the weight is sometimes okay, but compared to the ability of resisting the wind, it's stronger than the metal roofing. Next, we are talking about the metal roofing. Metal roofing is literally very popular nowadays because you can create any shape, any expression from the metal material. There are several material that you can find becomes popular. There's aluminum roofing, copper roofing, or steel roofing. And it's usually, if you have seen this, there are some part that is thick, but it's not as thick as terracotta tiles, or something like only like a board. So it's only one unit big like that. And the expression can imitate even the clay, the terracotta tiles like this, or you can have like this, or you can have like this. Any expression you can use it with the metal roofing. Why it is becoming popular? Because in the point of view of craftsmen, or maybe in the point of view of modern craftsmen who lives in the city, it is easily to be built. Like it's really lightweight, and you can just put it and then put it there and then arrange it. It doesn't have like to be one on one like the terracotta tiles. While as well as for the developer usually use this so that there is a uniformity. Because when we are talking about terracotta tiles, it's a man-made, even though it's you can like consider that it's not directly man-made. You produce it in a factory, but again, there are some different. There are small amount of differences usually, and you have to like match it. While for the metal roofing, it's definitely the same. So that developer or designer nowadays try to getting more interested on using metal roofing because of that. And now the benefits and the drawbacks is first is of course the energy efficiency. If we are talking about the energy efficiency, it's related to the building performance inside the building, where because it's very thin, usually thinner, and maybe if it's because if it's not thin or maybe it's thick, then it will be more heavy. It will be heavier compared to the terracotta tiles, so that it just need those thin thin sheet so that you don't have to create like a very thick one. So because it's thin, of course the heat transfer is easily goes to the room, so it potentially it creates overheating in the room and I think you can experience this if your house is using this type of roof. And then related to the durability and resilience, definitely is a plus. Because when you take a look, metal itself, it can last longer time. And even though you break it down, you drop it, then it will not break. Maybe it bends, but it doesn't break. So the durability and resilience is, of course, a plus on it. And then, of course, the lightweight, having a plus and minus. The plus is you can easily transport it, you can easily put it, and you can easily install it. But the lightweight itself has a drawback that is related to the wind load. So because it's lightweight, so it is easily getting blown away by the wind. So that's why the attachment of the or the arrangement of metal roofing, they always use overlap and then nail it. So you have nailing on it, bolt on some of the joints. And then the last benefits is the malleable. So malleable means that it is easily shaped. So because it's like a sheet, you can shape it like what you have in mind. It's more flexible than the terracotta tiles. For example, the terracotta tiles, of course, it will be like a surface, like flat surface, but you can create a circular surface on using metal roofing. That's why metal roofing becomes, if you want, if nowadays, if you want to create something dynamic or, I mean, not commonly found, people try to use metal roofing to express the design. Next, about the construction process. So after understanding the materials itself, we are talking about the construction process. So the construction process start from the ring bulk. I believe that you have studied about the ring bulk before. So the ring bulk is designated to distribute the load that is coming from the roof. That's why you start to put the rafter on top of the ring bulk like this. So I think this is what it looks like if we have a pitch roof, like a hip one, but it's a square. It's a square buildings. So and then after that you add hip on each corner. So this is the rafter, and then you put hip on it on each side to shape the roof, and then you add purlin on top of this hip, and then you put batten on top of it. So it's basically like that. And then on top of the batten, you have to cover it with the roof cover that you select. You can use terracotta tiles, or maybe you can use a metal roofing. This is the basic squarish building plan that I explained. but it can be develop more. So from square, it can be extended to rectangular shape. I believe that you have a rectangular one. If you have a rectangular shape, then you will you must engage with another type of rafter. So I can see that some of you haven't defined the rafter yet, like a proper rafter. So this is what it looks like. You actually have like a gable one like this, and then you have additional rafter here, so that it becomes like that. It's coming from this one that you cut. Wait a minute. This one, and then you cut it because it's extended, and then this extension here becomes one. So that's how you can think about creating a rafter. And then you put on top, you put another layer on top of it. So the distinguished thing is, again, there are multiple rafter, even the size sometimes is different. And then you have to consider what is the distance between each rafter or each trusses. So for example, you are using wood rafter, then you have to consider the maximum size of the wood rafter itself. And then so each distance is related to this the availability of the wood in the market, like this. So usually we have like maybe 3 or until 3.5 meters, but you can manage, that's the maximum one, but you can use a shorter one, so that when you have like a shorter type of this part, so that it doesn't it doesn't give it doesn't break in the middle. So those are what is related to the rafter. And then you add purlin. This is what it looks like, purlin. Oh yeah, sorry, I mentioned the purlin. So again, the size of this rafter is actually based on the purlin itself. That's why the maximum is 3 until 3.5 meters, is because of the availability of the purlin sizing. The purlin is created from the wood, and the wood itself has a limit on each length. But it's totally different with the trusses, steel trusses, because steel trusses doesn't have this strong ductile materiality. So because it's really lightweight, so you need to make the distance closer if you are talking about steel trusses, while this one is a wood rafter, so that you can separate it maybe until 3.5 meters. But for the steel rafter, steel trusses, you have to make it closer, maybe around 1 until 1.2 meters. So, and then on top of the rafter, you have the purlin, and the purlin itself definitely define this the distance between each rafter or each trusses. And then you put common rafter, and it's on top of the purlin. So the common rafter is becoming the support of the button. So that's why after the common rafter, you have the buttons itself, and the buttons helps you to attach the covering to your roof, like this. Oh yeah. So then we are talking about the coverings. The most important part about the coverings is about the felt and buttons. Again, after we are talking about the buttons, the previous one, it is becoming the part that directly make the covering in place. And then we are talking about the plain tiles. It is something that a method that is used to attach materials of roof cover. So plain tiles, interlocking tiles, and also slates. So if we are talking about the coverings, first we are talking about felt and buttons. So felt and buttons is a series of buttons, usually laid parallel like this to the ridge, and then they support the covering and keep the under felt in place. So felt is another layer. I don't think that it is commonly used in Indonesia, but you can find it in some buildings nowadays. So there is a layer in it, and then their function is to provide a fixing point between the covering and the structure. This configuration is actually just try to attach the covering to the roof structure itself. So this one is related to the covering, directly related to the covering. Um, After that, we have plain tiles. So this is the plain tiles. The plain tiles itself usually have a tile created from clay. It's almost like a terracotta one. But nowadays you can find a concrete one as well. So there are several parts. There are various type of plain tiles like this, and usually it is fairly small in size, so that you have to lay it double lapped. Double lapped mean like this. So this one, this one, this one. It's a double one, right? So there are three part that is layered into one area. So this is the button. So this is a roof button. So actually it is the element that hold the covering of your roof. So that's why there are several type of method to attach it with the roof button. So this is what plain tiles is. And then at the end of the laps, the top tile must overlap the tile two below it. So like this. So the end, and then you have to. This is what called plain tiles. Usually we are using this type of arrangement if the terracotta tiles is flat and also in a small size. So those are the plain tiles. And the next configuration is interlocking tiles. This is the most popular when we use terracotta tiles, because most of the time, majority of the terracotta tiles using something like hook like this, and then it will be easily attached to the roof button. So majorly of the terracotta tiles having this kind of shape. And again, it's made from clay or concrete, because nowadays you can find concrete tiles as well that is resembling the clay tile. And it is made because actually, as I have mentioned before, clay tile or terracotta tiles that is made from clay is really fragile. If you just drop it, and then it will break down. So concrete becomes another choice from practitioners. And then the thing that must be distinguished is the overlapping and interlocking at their sides. So again, if you compare with this one, it has it is having two layers or two elements underneath it, like 1, 2. That's why we call plain tiles. While this one is only having one underneath it, and it's just directly sit on top of another elements. And this is what it looks like for the terracotta tiles that you are going to use as your assignment. Even though, no matter how the shape is, like for example the circular one, or the flat one, it will be the same like this. And then can be laid single lap. Well, actually you can have the same configuration with this, but it wouldn't be effective enough. So that's why we use this. And then usually it is having a large size module. So large compared to the previous one, like this. The plain tiles. The plain tiles is usually very small, or maybe in Bahasa you can call it sirap, something like that. So those are the plain tiles, while this one is usually for in Bahasa called genteng or terracotta tiles. Next, the last one is the slate, and it's a double lapping, and usually it requires nail every slate. This particular configuration usually used for the metal roof. Well, actually, it's not like every slate. Usually, when you buy when you buy a metal sheet for your roof, then it will comes to a module like this, like this, usually 1.2 to 2.5, 2.4 meters. And then it is like this. The module is already like terracotta tiles usually. If you select those one like this, and by using this type of configuration, between one sheet to another sheet, you have to make an overlap at least in this part, and then nailed it. Why? Because it must resist to the wind. Again, because the nature of metal roofing is very lightweight compared to the clay tile or terracotta tiles. That's why we have to nail it so that it doesn't move or blown away by the wind, because it's very lightweight. Wait a second. Ooh. Yeah. Now, let's move on to the construction drawing. In the construction drawing, there are two types of drawings that that relates to roofing. Sorry. First one is related to the horizontal section or horizontal view. It doesn't have to be section all the time. So first is about the side plan. You will see the whole expression or the top expression of your roof in the side plan. This is the first plan, and then the second one is roof plan. In roof plan, you have to see the underneath part of it. That's why when we draw it, usually it's a top down. So we see the outer part and going down part. And then for the section plan, which is vertical part, usually it will be represented in the sections, of course. And then next is about the details. That's why when you try to draw it, you have to come from the bottom to the upper part. So that's why I mentioned here the bottom up. So these two drawings has a different method. That's why you have to understand it together. Now, this is the example of plan, like a roof plan. As you can see here, well, there are several parts that is different. The difference is each part here is having their own layer. This is showing how you put every elements of the roof, as well as the structure and the covering to this place, to the design. For example, you can see the ridge, you can see the hip, and then you can see the covering and any part underneath it. For example, this one, they have only the purlin, for example, and the ring bulk here. And then this one at common rafter on top of it, you can see the valley here, and then you can see the ridge cap here, while here you didn't see it. So you have to divide it. It's up to you. It's your expression. It's your creativity to try to communicate how you're designed. So this is what it looks like when you are trying to draw roof plan. That's why it's come from the top to bottom. So it's coming from the outer part to the inside part. So for example, this one, we have three commonly found pitch roof. This is the mono one. This is the gable. This is the hip that you have. If we try to take a look from this side, from the this is the elevation, and if you take a look from the top, this is like this. It doesn't have any ridge. Well, this one have one ridge here. For this one, if it is having a rectangular shape, then it definitely like this. So you have the ridge and you have the hip like this. And this outer part, we can consider it as this representation of the fascia. So that's why you can create like this as well. This is what it looks like in the outer plan. And usually this plan is used for the side plan, so that you can see the whole building on how it looks like in the side. And then next, if we are having non-square or non-rectangular building, how to build it, how to connect it, it feels like a little bit hard, but it's actually very simple. You have to try to break it down into two building mass or two area. For example, this one, this is one, and this is the second. So try to create a simple hip roof from those mass. And this is represented by 45 degree, just to draw it. And then move on. Try to connect the ridges. For example, this is one mass like this actually. That's how you draw it. So first thing, you try to separate the mass and try to build a simple hip roof and then try to connect it now. So the connection called the ridges. So try to connect it like this and then like this. And you can find a next one, you have to develop the valley and also the hip. This is what it looks like. For example, like this. And then of course you have to connect this one here. And then of course you have to connect this one here. That's why you can have so many options underneath it by those things. Again, the easiest way is try to divide it into several shapes. For example, like this, or maybe it's coming like this. It's up to you. Or maybe it's divided like this, and then like this, or like this, like this. Which one is the easiest way for you? So this one, for example, this one, and this one. And for example, this one, it can be like this, or maybe, well, yeah, this is the easiest one rather than the other ones that I think. So that's how you try to draw it. First of all, if you try to draw a roof plan, you have to define how it looks like at the outer part. And this is not the wall. Again, this is not the wall. It is the fascia. And the fascia is outer, an extension of the wall. So it's not representing the wall. Next, let's try to understand this. So when we are trying to draw the roof plan, first of all, we have to draw what it looks like. How the drawing is like the previous one I have mentioned before. So this is, for example, this is what it looks like. We have defined the hip and also the fascia, also the ridge. Again, this is the, where's my pen? This is the ridge. This one, the ridge. The ridge is the middle on top, and then the hip. This is the hip. And then if it's going like this to a corner, like down below, and then it definitely a valley. This is the valley. And then the border is the fascia itself. So here is the fascia. So you have to create that. And then after that, what you can do is don't forget about the ring bulk. So just try to draw the ring bulk. Well, actually, this is actually, you have to draw it first. I don't know why it comes second. So this is what it looks like, the ring bulk. This is what I mentioned about the protruding part. And then this is the fascia. That's why when you try to draw the plan, the roof plan, it's not from this perimeter, but this one, the outer part. So you have to have that. And then you put the ring bulk there. Then try to draw the hip. So after you know the ring bulk there, and then draw the hip like this, following those lines at the beginning. And then you draw the ridge to connect it. And then after that, you draw the valley. Well, actually, you can do it, the hip and the valley as well together. And then after that, you can draw the fascia. Fascia, it's like, just give a thickness on it. So that it's like that. So it's not just represented by one line. And then after that, you add the batten on top. And then after that, you have to consider the underneath part as well. So it becomes a lot messier now. So, but you understand the process. So from the top and it goes down so that you can put more stuff on it, and then it becomes full like this. So there's stretch, button, common rafter, and also purlin. And then after that, you have to draw the wood rafter. Again, when we are trying to define this one, well, actually, to define it, you have to understand where the shape is. My tip is when you have like the connection like this. Oh, sorry, it's usually becoming the part that is becoming the main rafter. So this is the main rafter because it's actually located in the joint of the roof. So the top part of the roof. Those must be the area of the main rafter. After the main rafter, you have to draw the additional rafter because you have a hip roof. It's not a gable roof, it's a hip roof, so that you need to have a support on that part here, 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 and here. So those are the difference between the gable roof and also the hip roof. If you have a gable roof, then you put your rafter around here so that it becomes flat. But this one is not. This one is sloping, so that you have to create another additional rafter, wood rafter. So if you would like to draw it, this one, it would be like this. Like this. And this one, it will be like this. It's connected on the side. So if we are trying to draw it in 3D, and it will be like this, and this one is in here. See, those are how you draw it, draw the rafter. It's not only applied for the wood rafter, but it also applies for the steel trusses. You still have to have a main support like this. Sorry for, it's raining hard in my home, so that's why it's becoming noisy. Now let's continue to, wait a minute. Next one, this is how you draw in section. In section, you start with the wall. That's why I mentioned that when you try to draw section on roof, you start from the bottom to and goes up. And this is starting from the wall and also ring bulk as a supporting point. And then you draw the principal, the rafter like this. And then add the purlin, of course. And then next is any additional stuff such as button, and then also ridge as well. And then add the outer part, such as button, the ridge cap, and then the covering, or maybe it's the terracotta tiles, or maybe the metal roofing. And then at the edge, you draw the fascia. So this is the definition. Those are how you draw the section. So that's why it's quite different between drawing plan and section. For the plan itself, you start from the top to bottom, while for the section, you go from bottom to the top part. Well, the detail, you will see this type of configuration. So there is detail E, D, C, B. If you notice, they are actually targeting the hardest part or the joint. That's why when we are talking about detailed drawing, it's actually something that must be informed correctly. Because if you don't inform it correctly, then it's not detailed. When students tend to select like easy detail so that they can draw it. But when you are in practice, well, you must choose the hardest one to finish. That's your detail. Because if you choose the easiest one and everyone knows how to finish it, then it's not a detailed drawing. But something that is really hard to finish and it's maybe your copyright, then that's the detail that you have to draw. That's why it's impossible to just draw something that commonly found or commonly practiced. So that's why detail is for something that is commonly known or something that is delicate enough so that you have to put the detail. So usually for the roof, the detail is located in the joints. For example, this one, this one, this one, this one, this one. And the majority, the most important part is the joint of this one, because this one, the detail B, is the joint of a different element. Different elements such as ring bolt is usually created from concrete. Then you want to attach it with wood rafter or steel rafter. It's two different materials. That's why they become the detail. Again, detail is something that is uncommonly found, or it's not something that is the same. So that's why you have to draw how it connects each other. That's the detail. And then another thing is the detail E, which is usually is found as well, because detail E, why is it important? It's because when you have a gable roof or even hip roof, these two surfaces must be finished. In drawings, it's easy, you just finish it. But when in reality, in practice, you have to define this meetings, this joint. If you don't define it, then it will be open and having leak and your roof is not working. So that's why you have to define it. That's why the most important part is those two for the details. When you draw the detail, of course, it started from the ring bulk, because it's the important part is how we consider the meeting of the ring bulk and also the rafter or the trusses. And always use axis, because the axis is becoming the guideline or the first thing that you have to consider. So use the axis. So this one, this is using the axis, or maybe in Bahasa we call it as. So this is the axis that you use for drawing the details, and then followed by the other part that you that is related to your drawings. So for example, you are having wood rafter, then you have to continue how the wood is joined. And then if you are using the steel trusses, then how the steel is attached to this wall, to this ring ball. Now, that's all for the explanation. I think, wait a minute, I still have maybe about an hour. I have an exercise for you, because roof is becoming something that is always avoided by students. So I have an exercise for you. So, but before the exercise, do you have any question related to what I explained? Please raise your hand if you have question related to that. Yes, Naufal?
I have a question regarding the assignment 3 about the metal roof. I still don't know about the hatch in the AutoCAD. Yes.
Oh, only the representation, you mean?
Yes.
Okay. Well, metal roof depends on metal roof that you are using. Again, because we didn't define the what it looks like, then you can decide what it looks like. There are several metal roofs, as I mentioned before. If you take a look on this, wait a minute, where is it? I will end this one. This card. Wait a minute. Oh, why? Oh, this one. So if you take a look on my example here, oh, where is it? This one. So there are many configuration and expression of it. So if you want to use the metal roof, the hatch depends on what it looks like for you. So you can use this one. There is a hatch like this, right? Like what you use as a like what you use as a wall hatch. Do you remember, Naufal? Like this?
Yes, bro. I remember.
Okay, you can use it, but rotate it. Rotate it. You can rotate the hatch. If you don't know, try to find it in the YouTube how to rotate hatch. So that when you have, for example, you have designed your roof like this. No, we have designed it for you. So you have like this. Then think about how it will be organized in this one. Is it like this or like this? Which one do you think? The left side or the right side? If you use a metal sheet, that is like this one, like this. So you have definition like this. Which one do you think appropriate enough for your design novel? This one, the right one, the left one, or the right one?
The right one, Bu.
Okay, why?
Because I choose uh the third material, Bu. The fourth material.
Okay. No. Well, actually, it's related to the rain. If you have something like this and you put it like this, so it will be it will trap the rain water in it. Well, this one, you just go directly there. It's a lot safer rather than you are using this one. So again, when you are trying to organize or assemble your roofing, then you have to consider what, of course, in Indonesia is the rain, because you have to eliminate the water as soon as possible. So that's the consideration. So is that clear, Naufal?
Yes, Bu, it's clear. Thank you.
Okay. Any other question? Yeah, Cindy.
Excuse me, but I would like to ask, relating to the assignment 3 too, about the roof. You explained about how we place the roof tiles up and down, but I'm still confused how about like the roof tiles
Uh-huh.
between two roof tiles along the roof.
Mhm.
I'm
What is,
still
yeah, which part
could
do you
you
confuse?
can you elaborate more about so how, I don't know, um, how to ask it, but can you elaborate more on the placing of the roof tiles along the roof, not like the one in the, like the interlocking tiles and the plain tiles arrangement?
Oh, I mean, not the interlocking tiles.
Like, can I speak in bahasa, Bu?
Yeah, yeah, yeah. You can use it. Yeah.
Jadi sepanjang atapnya itu, kalau di kasus saya kan pakai terracotta tiles itu, jadi antara terracotta tiles itu pemasangannya gimana along the roof gitu?
Along the roof from each tiles, you mean?
From from each tile.
All right. Okay. For this part, I'm afraid I have to explain it from the YouTube video, because you have to see directly how the craftsmen put it between each other. So wait a minute, I will try to find the video. Where is my browser? I usually have one with me, but I don't know why I forgot to put the video. Sorry. So I think here. I think this one. Oh, which one is this? Oh, I think this one. Wait a minute, I will share the screen. Wait. Yeah. So see, is that clear? That's the first one. Yeah. just that, like that. So close to the other part. So something like that, how to attach it. It's hard to explain, but if you see this video, then you can take a look on how we usually attach those roofing. Is that clear, Cindy?
Okay, Bu.
Okay.
I think I'll watch it later.
Oh yeah, you can try to find it in YouTube. There are a lot of video like that. So any other question? Is there any question before we start the exercise? How do we install the fascia and gutter? Saluran air is gutter. Gutter. So, well, how do you install it? It depends on the material itself. Again, when you try to ask about a very technical one like that, you have to see it in the video. It will be nonsense if I'm talking about it because you will forget about it. What I teach here is something that you have to understand fundamental, but the implication, you have to take a look on the YouTube by yourself. Again, if you try to find it in YouTube, there are a lot of video related to a direct building of a construction. So that it's a lot easier rather than I explain. For example, Cindy asked how to put the tiles. Yeah, that's how you put the tiles. But it's really hard to express it in words. So again, Hisham, you should take a look on YouTube if you try to understand how to install the fascia. If you try to here, because you are in the international undergraduate program, I suggest you to take a look on two type of video. First, using Bahasa. Second is using English. Because when you are using English, then you know the international, how the people outside our country apply the fascia or install the fascia into the roof. While if you are trying to take a look at in Bahasa, then you can find it how our local people attach it or use it. While for the kata itself, there are several kata actually, Hisham. So I will try to find it for you. So the kata itself, you can have like metal one. Just a minute. I will show you the image. This is a metal cutter. So it's usually already made in the factory. So you have just to attach it on the fascia, near the fascia. So it's only like this, just attach it like that. But there are another part or another cutter that you have. You can use concrete for your cutter. For example, like, wait a minute. Something like here. Where is usually if we have adjacent building, we tend to use concrete cutter. I think I will throw it. This one, it's a lot easier to understand. Wait, I will open it in the pic. So for this one, it's in the middle of the roof, like it's the cutting like that. But when you have adjacent building, for example, you have a limited area. For example, you have this kind of site, and then you want to build this part, whole of this part as your building, and then you want to use a pitch roof. Then usually, instead of using metal gutter, people will create a gutter from concrete. So this is the perimeter wall. Perimeter wall means that the wall that define your area. So it's directly adjacent to your neighbor, for example, and then create the gutter alongside this one. it can be full from there, but usually for me, I will put gutter as well at the back. And then this is your roof. So, so the rainwater basically will goes here. So those are the gutter. So what it looks like is actually like this in the section. If I put a section like this. So let's take a look at this part only. For example, like this is you have, that's why you have to draw from the bottom when you are drawing the section. So at the beginning, you draw the ring bulk like this. And then this is the wall. And then this is your rafter or trusses like that. And then put the wait a minute. I'm a bit confused about it. Oh yeah, the purlin. You draw the purlin, and then you put another layer on it, and then until the covering, you draw it, and then finish it. And usually the fascia will be here. Wait a minute. This is you have a common rafter here, and it usually attached to the common rafter here to stop it from going down. And then from here, I usually draw the create a structure like this, a concrete one, so connected directly to this area, or maybe I have an extension with the ring bulk like this, and then create. This is the area like the perimeter wall. This is the perimeter wall. So that's when the rain comes like this, it will flow down to here. But you have to make sure that this area, like this area, I will choose another color, like green, for example. This area, specifically this area, must have a wet water resistant quality, like a best water resistant quality. So usually I put it like higher, so that if you take a look on the other part, wait, I will draw it. For example, if you have the roof finish here and all the roof structure here, I usually put it a little bit higher so that I can add here the gutter here. The concrete gutter is here, so that when it fulls of water, it doesn't goes back into the room because of the leak. Not only the leak, the unsolid, not solid part or the void part of your roof. So usually I create something like this. So this is another gutter that you mentioned before, that you asked. Is that clear, Hisham?
Yes, thank you.
Yeah. Any other questions? No? Okay, if you don't have any question, I will. You need to open your SketchUp for this exercise. So I will give you the file through the chat box. Wait a second. Where is it? State modified. Yeah, this one. Exercise. It doesn't have anything in there, but I will open the file as well. Sorry for the noise of the rain. My house is a very open house, so even though there is no doors here, that's why it's a little bit loud. Wait a minute. So maybe if you have opened your files, then you can see this weird building plan. I made it weird so that you can try to think about how it looks like. So the exercise is asking you make a preliminary 3D for roof. So you have to create a hip roof here. I didn't ask you about the material. You can use any materials that you want. and you can use any you can use a wood or trusses or steel trusses that you want, but please make preliminary 3D model for roof of this building. So what does it mean by preliminary? Means that you create just like one surface or something like only one surface. You don't have to put the thickness of it, but each element should be color coded. So you have to and you can create a different color of the cover of the covering, and then also you have to put different color on the trusses or the metal sorry, the wood rafter, and then also you have to put different color on the configuration of the, what is that called, the button. So there are three main things, and what you have to define is, first again you have to define the fascia first, the outer part, and then try to draw and then try to define the hip, the valley, if any. There must be a valley here, and then you have to draw hip as well as hip, valley, ridge, yeah, as well as the covering that you choose. So it must be a hip roof. Hip roof means that you don't have a gable on it, so you have to work with it. Is that clear about the exercise?
Excuse me, but I want to ask something. So in this,
Yeah.
Suara saya udah kedengaran ya, Bu?
This one is clear.
Okay. So for the exercise itself, is it an exploded axonometry or just like a roof plan?
No, it's just a roof plan. You can throw it in a roof plan. You don't have to create the exploded axonometry. No, it's just roof plan. What you have to send me is your SketchUp file. So I want to see how you make those words. So it's not something that you can edit or just copy paste it from any other drawings from the internet. So it must be a SketchUp file. Is that clear, Sukma?
Yes, Bu. Berarti ini kalau di SketchUp itu dari top view aja ya, Bu, ya berarti?
No, it's a 3D one. It's a 3D one. Okay, guys, I will show you an example of what the exercise look like. Well, actually, it tries to. I'm trying to get an understanding of how you understand about the roof itself, because it's something that always been avoided by students. So that's why we are trying to understand how you understand to understand your understanding. So I will open my SketchUp first. I will give you an example, like literally like a very easy one. Wait. Okay. So it doesn't have to be like very detailed. So I'll show you here. That. So draw it. For example, you draw like this, the plan. Well, I will draw it quickly. And then here. And then you create the ring bulk like that, and then you put it like that. And then try to create the fascia, or how you draw it. I usually draw like from here, and fit here, and then create an offset like that, for example. And then just try to create a 3D one. And then, for example, I started to build my first rafter. So for example, if I want to create rafter, then I have to define where is it located, right? So where is my protector tools? This, for example, G5. That one. So I have to build my stuff around here. So whatever. This, and then just you can create your own. So this is my first rafter. So I'll group it and then choose another color and then another rafter here, for example. Or I cross the boundary, sorry. So for example, it's just a quick drawing, don't just stick to it. So it's very, the slope is very high. So like this, oh, this is my first one. And then I will create the covering like this. Bam. And then you follow the continue, you just continue how it looks like. So it's actually 3D one, but it's only a preliminary one. I just want to know where you put it, how you design it. That's just this, and then finish to the whole one. And then I can select, for example, when you have a finished model, then I can take a look on your code. Don't forget to create a legends here so that I can understand which one is the covering, which one is the structure, which one is the fascia or stuff. So you just give color. And I don't ask you to give thickness. It's just a surface. What I ask is how you try to apply what I have explained in the previous in the lecture. So is that clear, Sukma? Just like that. Yeah, it's not like a very complicated one, but I just want to know how the foundation works for you. So is there any question related to the exercise?
Excuse me, I want to ask a last question. When is the deadline for this exercise?
Okay, the exercise must be submitted at 4 because the class will be finished at 4. I know some of you will go like, no way. But the remaining time is allocated for the exercise. So that's why I didn't ask you for a lot of stuff. Just draw it in SketchUp, and then you have to submit it in the classroom maximum at 4. So that I can evaluate how you understand about that. So is that clear?
Yes, Bu. Thank you, Bu.
Okay, so Cindy, do you want to ask?
Sorry, but I want to ask. So from the PDF file, does it include the fascia or it's just the rainbow? I think I've missed it.
All right. So it's only the plan. It's only the wall. It's not related to the fascia. You can define your own fascia. I just want to know where how big is it.
Okay.
Okay. Then is there any question related to the exercise? No. Okay. So after you submit, I will give you a feedback, and I hope you don't ask because it's an evaluation. No, I didn't give you mark. No, it's not related to the assignment, but I want to know how well you absorb the lecture and you understand how to apply it in your drawings. So that's why you have to draw like a preliminary models. This is 3:29, and I hope you can start from 3:30. Is that enough for 30 minutes? Should I extend it to 4:30?
Yes, please, ma'am.
Okay,
Yes,
so okay, but
Please extend it.
wait a second. I have just opened the classroom and I realized that Pak Ngurah has another deadline for you, for the group who has tutorial with Pak Ngurah. Wait a minute, I check what time is that. I need to match it. So it's on it's Saturday. No, oh, it's different. Okay, so today you will have to submit that. I think I will extend it into 4:30 because it's already 3:30. So you have an hour to figure out how you plan it. And then submit it in SketchUp file, but make it 2017. Okay, I have the updated one, but I'm afraid that there will be a crash or whatever happening. So try to save it in 2017. If you have 2020, maybe I don't know what SketchUp I am in right now. Well, I'm check. Oh, it's a 2020. So if beyond 2020 or use 2021, just try to convert it in 2020. Just use the save us in 2020. So that's the exercise. Is there any question? No? I will open the assignment, the submission in the classroom after this. Maybe Pak Ngurah want to add something or give information, Pak Ngurah?
No, I think it's enough, Bu Fenty. Very
Okay.
much.
Okay. Yeah. Okay. Thank you. And then now, I will end the class. And unfortunately, if you don't write or take notes on my lecture, then you miss how to do it for your exercise, because the recording is available 30 minutes after the meeting ends. That's why you need to take a look on your notes. So that's what I want to mention. I will share my recordings, but unfortunately it's not available. So you have to depend on your notes and your memory if you don't take notes. So that's all. So I will end the meeting now. You can start to work with the exercise and try to make it as clear as possible, so that we can understand your drawings. Just don't copy paste from your friend, because it's for your benefit. Okay, so you can discuss. Do you need a discussion among the class, so that I can leave this Zoom to you and we leave the class so that you can discuss with among your friend? Do you need the Zoom? Hello, you work with it. Cindy, do you need the Zoom so that you can chat or discuss with your friend?
Probably, I think so, but I don't know about the others.
Okay, so what about the others? Do you need the Zoom?
It's okay, ma'am. Just leave the Zoom open for us.
Okay, so you can use the Zoom. Then I will make, who wants to be the host? I will stop my recording now.